This is lesson 2.2.b. Our objectives are to identify domain and range from a graph and be able to write domain and range using a couple of different methods. The point of this is to be able to describe our solutions of functions, and our solutions of functions always come as either domain or range or both, and we want to effectively describe those using proper notation. All right. You might want to take out some paper and pencil and write down some notes as we go. So this first slide consists of a little bit of review. The domain of a function consists of all possible x values. We know that. We can find the domain of a function on a graph by looking at the graph. We look at the line on the graph and we determine horizontally where it's going. So the graph's extension horizontally shows us the domain. Versus the range, we know are all the y values. In order to determine the range of a function on a graph, we would look at the vertical extension of the line or the shape that's on the graph. In order to write domain and range today, we're going to use inequalities, which we just had a lesson on inequalities, so you should be familiar with that. And then we're going to also use interval notation. As we're going through today, both these methods are useful, and I personally think the interval notation is a little bit easier to use, but you can use whichever method is more comfortable to you as we move forward past this lesson. Let's look at some examples. Here's something that you're familiar with. This is a graph of just some individual points. This is not a continuous function as there's no line in between and connecting each point. So our domain truly consists of the values at each of these points, the x values. And we found our domain by just looking at those. So we have a 1, a 3, a 4, and a 6. And remember that we write these in order from smallest to greatest, and we only include each number once. Our range, if we go from smallest to greatest, is down here at -2, then +2, and then +5. Notice that we have two +5 values, but we only wrote 5 once. Okay, now let's look at a line, something that is continuous. How do we write the domain for this? So notice, first of all, we have to figure out where this line is going. We have to figure out which y values that it actually consists in our domain. So let's first analyze our x values. If you'll notice that this graph, even though there's a slope, this line is actually angling to the right and it's angling to the left down here. If I were to tilt this line and make it horizontal, I could redraw it like this, and then I could clearly see that this right side is going out to something that we call infinity. It never stops. A line is continuous in both directions. So it never will hit a number, it'll just go out to the direction of positive infinity, whereas on the left side, it will go out to the direction of negative infinity. Okay, so our domain ranges between negative infinity and positive infinity. And if we look here algebraically, we can write it as x is greater than negative infinity and less than positive infinity. And remember, that's a compound inequality. So this is happening at the same time. Our range, on the other hand, is, remember, vertically from top to bottom. So if we start with our smallest, this graph is heading down, 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 down towards negative infinity, and up, up, up towards positive infinity. Again, if I turned this graph to the left, I could draw a temporary line here, and it illustrates that I do go from negative infinity to positive infinity. So even though it's angled, we can see that this graph extends up and to the right, as well as down and to the left. And notice that our range is written the same way as our domain. We go from negative infinity to positive infinity. So y is greater than negative infinity and less than positive infinity. Now notice that we don't include infinity. We don't say greater than or equal to or less than or equal to because infinity is not an actual number. Let's explore some interval notation. If you'll notice, this is a little bit easier to write. It's just negative infinity, comma, positive infinity, meaning that we go between negative and positive infinity for both. These are all real numbers, so there are no numbers excluded. Every number is in the solution here on this equation for this line. Couple things that you need to know, and that is how to write interval notation. So in this case, you see that we have some parentheses, Anytime we have parentheses, that means that we include, that means we exclude, start again. That means that we exclude the number that is next to the parentheses, so it's not part of the solution. You will see coming up in the next example that we also use brackets. And if we have a bracket, that means that we include the number that is next to the bracket. And this is very similar to closed circles and open circles on number lines. In this case, we would have a closed circle because we would include the number. Now it is possible to have combinations. In this case, if we have a bracket, we would include the number next to the bracket, but we may have a parenthesis on the other side, so we would exclude the number next to the parentheses. Okay, and let's look at some examples of that. In this next graph, we are starting here at this point, which is -2, 0, and let's write that on here. And we are traveling down, and this line continues on forever. So let's identify where this line goes. Well, it's heading to the right. So if we're thinking about domain, we start at -2, this x value, and it actually does go to the right out here somewhere to positive infinity. It never stops. So if I draw where this line is going, it's going in that direction. Okay, and if we look at our domain over here, we say that x is then greater than or equal to -2, meaning that we include -2 because of the closed circle, and we extend to the right forever. It's greater than or equal to -2. Now let's examine our range. So notice this line is angling down. So we start down here somewhere at -infinity, because it'll never end, it'll continue to go down forever. And if we travel up from -infinity, it does stop here though at 0. So we're down here at -infinity, and then it stops right there at 0. If we look at how to write our range, we say that all the y values are less than or equal to 0. So here's 0, and then all the way down here to -infinity are all the numbers that are less than or equal to 0. Now here's an example of using a combination of brackets and parentheses. So notice we have a bracket around the -2 because we are including the -2 in our domain. And in this bottom example, we have a bracket around the 0 because the 0 is also included in the range. So we go from -2 to positive infinity. And in the bottom example in the range, we go from -infinity to 0. Notice that we only put parentheses around the infinities because, again, those aren't actually numbers. Let's look at a third example. In this example, we have endpoints. So we will not be using infinity because the graph does not extend in any direction indefinitely. So let's write the coordinates of this endpoint. This looks like -5, 1, and this one looks like 4, 3. And that will help us to better identify the domain and range. So if you'll notice down here, the domain goes between -5 and 4, right here, whereas our range drops right here down to -4, but it doesn't go any lower, and it extends up here to +3. So sometimes making a quick sketch on your graph can help you better write your domain and range. If we look algebraically, we say then that x ranges between -5 and 4, so x is greater than or equal to -5. Notice the equal because we have a filled-in circle. And x is less than or equal to 4. Compound inequality, this is happening at the same time. For our range then, we say that x is greater than or equal to -4 right here. And it's less than or equal to 3 up here. So our range is between -4 and 3. Now if we look at interval notation, it's the same thing. We go between -5 and 4, and we include those numbers, so we have a double bracket. And our range goes between -4 and 3, and again we include those numbers, so we have a double bracket. try one more example and then we'll do a couple on our own. Okay, so in this case, we can see right away that our domain starts here. It goes between -3 all the way up to +2. And again, sometimes it's helpful to write in the coordinates of your point. So that goes -3, 5, and this point here is at 2, 0. So our domain down here extends horizontally between -3 and +2, whereas our range vertically starts here at -4 and rises up to 5, but does not include 5. So when we write our inequalities, we say that x goes between -3 and 2, but notice the open circles again, we do not include those values. So x is greater than -3 and less than 2. Interval notation, we then use parentheses. It ranges between -3 and 2. Our range, on the other hand, goes between -4, but we have a closed circle, so it does include the -4, and +5 up here, but open circle, so we do not include the 5. So our y ranges between -4 and 5, so y is greater than or equal to -4 and less than 5. Okay, and here's some more explanation about why we need to use a bracket around the -4. Okay. All right, let's try a couple on our own. So why don't you pause the video and see if you can identify the domain and range of the function from this graph, and then come back and we'll compare answers. Okay, hopefully you have some good answers and that you made an attempt. Let's look first at our domain. So if we notice that this is going to the left, there's an arrow. So if we think about how far to the left it's going to go, well, it's going to go to -infinity. Let's look at where it goes on our right. Again, we have an arrow, so we know that it's going to continue to go to the right forever, +infinity. But now let's look at our range. Our range starts here at 0, and it goes all the way up to +infinity. Okay, these arrows are continuing up forever. So let's look at algebraically. Let's look at our domain. So we know we're dealing with x. So x is in the middle, and what does it go in between? It goes in between -infinity, and it goes all the way up to +infinity. So x is greater than -infinity and less than +infinity. Using interval notation, we write -infinity, +infinity with parentheses, since infinity is not a number. Now let's look at our range. So we're dealing with our y values, and we know that our range goes between 0 on the small side and +infinity on the large side. Since it actually does hit 0, we know that it includes 0, so we know we need to go greater than or equal to 0, but less than infinity. As far as interval notation, then we need a bracket because we are including the 0, and we go all the way to infinity parentheses. All right, good. Let's try another example. Again, go ahead and pause. Try this example on your own, and then come back. Okay, let's compare our domain and range here. So our domain, let's do that first. It looks like we are here at the -4, and then we head to the right all the way out to +infinity. Okay, so let's write that. We have x ranges between +infinity and -4, so we just need to know what type of inequality sign to write. Since we have a closed circle here at -4, we know that we include that, so we have a greater than or equal to. And then a less than sign that goes with our infinity. Writing this in interval notation, we range between -4 and +infinity, and we have to make sure to put a bracket around the -4 due to the closed circle. All right, let's look at our range. Our range is down here at 2 and goes up to +infinity. Notice the direction of the arrow, it's going up. So if we're dealing with our range, we know that we are also ranging between 2 and positive infinity up here. We know that we are less than positive infinity and greater than or equal to 2, again because of the closed circle. Writing that in interval notation, you should have written a bracket 2 comma positive infinity. All right, last example. In this example, we have, it looks like closed circles on either side. We have one here and we have one here. So when we're thinking about our domain, we are going to go from here. This looks like 1, 2. So this point right here is 1, 2, 3. This point is 2, comma 0, or 3, sorry. And this point out here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 4, 5, 6, it looks like. So our domain goes between 2 and 13. So I'm going to go ahead and write 2, 13, and then put my x in the middle. All I need now are my signs. Well, x is going to be greater than or equal to 2 and less than or equal to 13. Writing that in interval notation, I would need brackets for both. But as you can see, it's a little bit easier and quicker to write this in interval notation. Now let's think about our range. So our range goes here 1, 2, 3, all the way up to 6. So I'm going to go ahead and write our range here. Oops, I read our domain a little too high. So we're going to go from 3 to 6, and we are including the 3 and the 6 in our solution. For algebraic notation, I'm writing the 3 and the 6, the y in the middle, and I know that we include these, so I'm going to have a greater than or equal to and a less than or equal to on the right. Okay, so hopefully that is helpful for domain and range. And if you have any questions, go back and review this lesson. Make sure you take some notes on brackets versus parentheses, and then go ahead and try the practice which follows the lesson.